exponential function.
This is the continuing of 5.2, right?
We are doing 5.3. This is 5.3. 5.2 we already did yesterday. We are on 5.3 now. So we are on page 279 right now. So laws of exponential function. So what it says is if s, t, a and b are any real numbers with a greater than 0 and b greater than 0, they're saying if s, t, a and b, they can be any real numbers, but my a and b should be positive numbers, they cannot be negative numbers. Then if I have something as a to the power of s, a is raised to power s, and I'm multiplying with, again my base is a, and I'm multiplying with my, this time the power is t, this time the power is t, this is actually equal to, so when you have the same base, different exponents, same base, different exponents, multiplication changes into addition. So you, base will still remain a and you add the exponents. This is the first property, first law. You are learning about exponential functions. Example, if I say 2 to the power of 3 times 2 to the power of 5. 2 to the power of 3 times 2 to the power of 5. In this case, I can see the same base is gonna still remain the same. Since this multiplication, I can add the exponents. So it's 3. So it's become 2 to the power of 8. If you don't understand, see, I can prove this. 2 to the power of 3 means you're multiplying 2 3 times. I'm just proving this. What I did is correct. And 2 to the power of 5 is you're multiplying it 5 times. See, in total it becomes, if you check 1, 2, 3, 4, 5, 6, 7, 8, it becomes 2 to the power of 8. This is a proof. You don't have to do the proof, you just need to know how to do this. If you have same base, different exponents, multiplication changes into addition, and that's how you get 2 to the power of 8. Any question? I'm just talking about multiplication right now. When you're multiplying two terms. Okay. Next property is, if you have a s, okay, you have a function a s, and this whole thing is raised to power t. This whole thing is raised to power t. This is actually equal to a. You can remove the bracket and multiply the exponents. And you can multiply the exponents. Example, I say 3 to the power of 5 to the power of 2. This is actually 3 to the power of 5 times 2, which is 3 to the power of 10. So if you have as and then a bracket and t, you just basically multiply. Okay, let's do third one. Third one, it says a, b, and then you're raising this whole thing to s. It's basically, note you're multiplying the terms inside. I'm just talking about multiplication. If you're multiplying, you can distribute the exponents. If already they don't have the exponents, actually they have the exponent as 1. If there is no exponent, that means their exponent is 1. So you multiply. A 1 times s becomes as, times multiplication remains multiplication, and b to the power of x. Distribute the exponent. So if I say 5x to the power of 2. What is it equal to? So 5 and x are being multiplied with each other. So distribute. It becomes 5 to the power of 2 times x to the power of 2, which is 25x square. You can distribute like this. Okay. The fourth one says 1 to the power of s is always 1. No matter how much you raise your 1 to, it is always equal to 1. If I say 1 to the power of, example, if I say 1 to the power of 10, that means I'm multiplying 1 10 times. I'm still gonna get my answer as 1. Any questions, anyone? So far, first 4 laws. Let's go to the fifth one here. Fifth one says if you have a to the power of minus s. Now it's a negative exponent. You can make into positive. How? By interchanging the place. It's in the numerator. Put it in the denominator. A will remain a. It's just that my exponent will become positive. Change its place and make the exponent as positive. So suppose if I had 2 to the power of negative 3, I say find the value of this thing. How you can do is, I don't want to deal with negative exponents. It's in the numerator, take it in the denominator. 2 will remain 2. Negative will become positive. And I know 2 to the power of 3 is 8. So my answer is 1 over 8. So if you have negative exponent, you basically change the position. If it's in numerator, make it into denominator and make it positive.
Professor, can you just scroll down a little bit? I just want to see number 4.
Yeah. Just a second. Number 6. The last one. It says any number to the power of 0. Any number to the power of 0 is actually equal to 1. So if I say what is 2 to the power of 0? It is 1. 100 to the power of 0? It is also 1. No matter what number you raise to power 0, it is always equal to 1. These are the 6 laws of exponential functions. Any questions with the 6 laws of exponential functions? So you will be using this, you will be using all these laws to solve exponential functions. So basically today what we are learning is how to solve exponential functions. And for solving you will be needing all of these laws here, which we did, these 6 of them. So let's see here how to do that. So first of all, if you have given something like, note, if you have something like a to the power of u and it is equal to a to the power of v. If you have same basis with equal to sign and your exponents are different, then you can actually just cancel them and your exponents will be equal to each other. So if I say example, I say 2 to the power of x plus 5 is equal to 2 to the power of 3. Since my bases are the same, I can equate my exponents. It becomes x plus 5 is equal to 3. Subtract 5 both sides, you get x is equal to negative 2. You can solve like this. Since your bases were the same, you can equate your exponents and then solve for x. So this is one we are going to use. The laws and this property we are going to use to solve our exponential functions. So example, let's take an example here. It says solve 4 to the power of 2x minus 1 is equal to 8 to the power of x. You need to solve this. Can I have Christopher?
Yes.
Okay. So you need to find the value of x in this case. Okay. First of all, are my bases the same?
And no.
Can I make my bases same?
Yes.
How?
You can, because 8 is a power of 2,
And 4 is
and
also.
4 is a power of 2.
So 4, how can I write? 2 to the power of?
The 4 is 2 to the power of 2.
And then outside it will be 2x minus 1. And what about 8?
And then 8, it would be 2 to the power of 3.
Perfect, perfect. So what he did is, he's trying to make the same base. He knew you can make both of them as 2 to the power of something. He wrote 4 as 2 to the power of 2 and 8 as 2 to the power of 3. Make sure you put in a bracket because you're changing, so make sure you put in a bracket. Okay, you make the same base. Anyone who did not understand this step? How I did this step here? Everyone got this step here? Okay.
So basically reversing the 8 and 4 into 2, right?
Yes, yes. You're trying to make the same base. That's your first step, because if it's the same base, you can equate the exponents and then solve. That's easy. Your main purpose is to make your bases the same. And I know I can write 4 also as 2 to the power something, 8 also as 2 to the power something. Now remember, we did a property here. We did some property as a to the power of st. We did this. It was equal to, okay, can I have Miguel? Miguel? Okay, Hugo?
Yeah.
Okay, we did this property a s, this thing, it is equal to what?
So it's going to be a s equal to the power of s times
T.
7. T.
T.
I'm
So
sorry,
you,
T.
yeah, you multiply. You basically just multiply. So can you tell me what
T.
will this become?
You mean the
actual problem.
actual problem? So it's going to be 2 on the first 2 is going to be 2 to the power of 4 x minus 2.
Perfect. Is equal to?
It's equal 2 to the power of 3x.
Perfect, perfect, perfect. So you got this thing. I use this property from here to here and I multiply. You have to multiply 2 with this whole thing. 2 times 2x gives me 4x and 2 times negative 2 gives me, negative 1 gives me negative 2. And here 3 times x gives me 3x. Now note, my bases are the same. My exponents are different. Now I can use this property here and put them equal to each other. So you get 4x minus 2 is equal to 3x. And then solve for x. I take x terms on one side. I get x minus 2 is equal to 0. At 2 both sides, you get x is equal to 2. So that's how you solve. If your bases are not same, you try to make your base same and then use up laws which we learned before and find the value of x. Any question with this one? Okay. Let's do one more example. I'm going to do one more example here. So next example you're given is e to the power of negative x square is equal to e to the power of x to the power of 2 times 1 e to the power of 3. You have to solve this. Don't get confused by e. E is natural exponential function. It is something 2.71 some number. It is a normal number. They're calling it as e. Don't get confused by e. E is just a number. They're calling it e. So you need to solve this. Can I have Angel?
Yeah.
Okay. All of them have the same base, right? All of them have the same. This also has e, this also has e, this also has e. But I need something as a to the power of u is equal to a to the power of v. Then only I can put as u is equal to v. Right?
Oh,
So first I need to
Uh-huh.
combine these two. I need to combine these two so that I have something like this. I cannot have two terms here. I need to combine this and make it into one term.
Oh, so it's gonna be at least on the right side of the equal sign.
Yes.
It's gonna be e to the power of 2x.
Okay. And then how do I take this on the top?
Is it we turn it to e to the power of -3?
Exactly. You change the position and change the sign of the exponent. Perfect. Perfect. I'm using the property. What property he used here is, first property he used is a to the power of st is equal to a. He multiplied. And the other property he used is, if you have a to the power of negative t, it becomes 1 over a to the power of t. He used it backwards. Okay. So you get, what about this? How do I combine this, Angel?
1 second. Oh, is it?
Mm-hmm.
We could just we can just pretty much make it e to the power of 2x minus 3.
Yes, exactly. Since my bases are the same and it's multiplication, I can just add my exponents. It becomes 2x negative 3. Now it is exactly in this way. Same base, different exponents, equal to sign. Just put them equal to each other. So what property he used here is a times s times a times t is equal to as plus t. He used this property here. And then solve. So I take every term on that side. I subtract 2x and add 3. I get minus 2x, positive 3 is equal to 0. And you know now how to find the value for this thing. Quadratic formula. A as -1, B as -2, C as 3. Put in the formula. X as -2 plus minus square root of -2 whole square minus 4ac over 2a. You get 2 plus minus square root of 4 plus 12 over -2. You get x as 2 plus minus square root of 16 over -2, which is 2 plus minus 8 over, 4 over -2. Solve, put it into two forms. X as 2 plus 4 over -2 and x as 2 minus 4 over -2. When you solve, you get here -3, here you will get as 1. So these are your two answers. Any doubt with these problems? Basically, you should know how to use the properties. You need to a position where you can use the property a to the power of u is equal to a to the power of v. Once you have that, you can put basically the exponents as equal. Do you have your books? Everyone has their books? If you have your books, I want you to go to page 291. If you have your books, page 291. Okay. I want you to start doing odd problems from 63 to 87. 63 to 87, all the odd ones. So you'll do 63, then 65. I want you to start doing these if you have your books with you. If you don't have your books, let me know.
I mean, I have my math lab, but I don't have.
You don't have it? Okay, I'm going to write it like this. Okay, I'm going to write it like this. 63 is 7 to the power of 3 is equal to 7 to the power of x. I'll write here. 65 is, you can just copy from here, is 2 to the power of negative x is equal to 16. You basically need to solve. 67 is 1 over 5 to the power of x is equal to 1 over 25. 69 is equal to 2 to the power of 2x minus 1 is equal to 4. 71 is 3 to the power of x. 3 is equal to 9 to the power of x. Start doing these problems. Rather than copying, just do first problem, find the answer, and then start doing these. 8 to the power of negative x plus 14 is equal to 16 to the power of x. So these are the problems we'll be doing right now. Nicholas,
Yes.
what do you get answer for the first one?
The first one, so it's 7 to the third power equals 7 to the x. So Actually, I think what I did was wrong. I moved the 7 to the other side and I subtracted it.
No, you don't have to do that. No.
Yeah.
So you try to take out the first thing you had, the laws. Remember we did the laws here?
Yeah.
You use those things, and also in these laws, so seventh one, you can write your law as a to the power of u is equal to a to the power of v, then u is equal to v. Okay, one of these laws you have to use. Let's see. You have some base, some exponent is equal to the same base and some different exponent, right?
That would be the third law.
So third one, you're saying third one to use?
Yeah.
So third one has a times b, and that is raised to power here. You're not multiplying here anything, right?
No.
So it's not that one. Which one do you think? Compare C. See the seventh. See the seventh
number one.
See the seventh one.
Seventh one.
You have a to the power of u is equal to a to the power of v. Then what happens? U is equal to v. If your bases are the same, there is an equal to sign. Your exponents are also equal. Let's see here. My bases are the same. My exponents are different and there is an equal to sign. Then what happens?
It will just be the x will equal to 3.
Perfect. You got it. Yeah. You're gonna give me the answer for 65 one also. Try to do this one.
Okay.
Samantha,
Yes.
did you do the 67th one?
Oh, I'm doing it right now.
Would be the negative x.
Okay, so first of all, you need to. Okay, wait. Rather
We're
than
gonna
make.
move the 2 to the 16.
Yeah, so you need to make the bases the same. How do you make the base the same? Here I already have my base as 2.
Mhm.
I need to make this the same. How can I make this as 2 to the power of something? Can I write 16 as 2 to the power of something?
Square root of 4.
No, I have to write 2 to the power of something.
Oh,
2 to the power of 4.
I mean,
So
2 to the
six-
power of 4.
Yeah, you can always see here 16, 2 times 8, 2 times 4, 2 times 2. So how many 2? 1, 2, 3, 4. So you can write 16 as 2 to the power of 4.
Yeah.
And then what happens?
And then you move over the 2 to the right.
Why you want to move it? Remember again, same base, equal to sign, different exponents. What happens?
Oh, so we just
You're correct?
that's just our answer, right?
Yeah, what is the answer?
Negative x equals 4.
And what is the value of x? I need to find the value of x.
It's negative 4.
Yes, perfect. You got it. So basically what you're trying to do, Nick, here is you're trying to make your base same and then you're putting the exponents equal. Once you got your bases same, both sides you got the same base, you just put your exponents equal. Did you get it?
Yeah.
Perfect. Okay. Samantha, did you get your answer for 67th?
I was looking at the examples,
Okay, let's see.
but
Let's see.
I don't know.
Let's do it together. So you have 1 to the 5 to the power of x as 1 over 25, right?
My guess is that you find the same base.
Yes. So how do I make the same base? 1 over 5 is here. Can I write 1 over 25 as 1 over 5?
You can, yeah.
How can I write it? What is 1 over 25 as 1 over 5 to the power of what?
1 over 25.
Can I
Well,
write it as 1 over 5? I need the same base, right? I need 1 over 5 also here if I have to make the same base. Can I write
wouldn't
it?
to the power of 2.
Yes, it becomes 1 over 5 to the power of 2. I can write whole 2 also because 1 times 1 is 1 only, right? It does not make a difference. Are you getting my point?
Yes.
Okay, so what do you get?
Can you switch it up to a whole number and then be 5 to the power of x is equal to 5 to the power of 2?
So if you're changing that, what you can do, you can make 5. If you want to change place, you was like, oh, it's a denominator. I don't like denominator. If you're taking in the numerator, you have to make the exponent as negative. If it's positive, it will become negative. Okay?
Yeah.
Similarly, in this case, it becomes negative.
Yeah.
So what do you get?
Negative 2 and then
Negative x is equal to?
and it will be x equals 2.
Perfect. Did you get it? How to do it?
Yes. Yes, that was my guess. I just wasn't sure.
Yeah, perfect.
Thank you.
When it's at 1/5
Yeah.
to the x power equals 1/5 squared,
Yeah.
can't we just take out the 1/5? Like we can stop there and just have it equal
Yes,
x
is equal
equals
to
2.
Yes, exactly. Yes.
Okay.
I mean, she wanted to do it that way, but that's okay. But here directly you can say, since your bases are same, your exponents are directly equal. Carly?
Yes.
Okay, have you done 69th?
69. Okay. What I did first is I changed the 4 to 2 to the power of 2.
Okay, so what did it became? 2 to the power of 2x minus 1 as?
2 to the power of 2.
Okay, perfect. And then what did you do? Next step.
And then I put 2x minus 1 equal to 2.
Okay, 2x minus 1 is equal to 2. And then you solved it. What did you
And
get?
then I added 1 to both sides and divided by 2. And then I got x as 3 over 2.
Perfect. Perfect. So in this case, you get
And-
x as 3 over.
And then I plugged x as 3 over 2 into the original.
1 and check your answer, right?
Oh, yeah.
Yeah, perfect. Correct. That. Any doubts till question number 69? Anyone? Jelena? Jelena? She's not here? Jelena is not here. Okay. Axel? Axel? Not here. Alejandro? Alejandro? Not here. Jose?
Yeah,
Okay, 71.
71. I got x equals 0.
So you have 3 to the power of x cube over 9 to the power of x. What did you do?
So I needed to get the 9 to the x to have the same base. So it should be 3 to the
X cube.
third times x. So 3x. Oh, it's 3x equals 3x.
So what can I write 9 as?
3 to the 3
Mm-hmm.
to the x.
To the second power.
Oh yeah, my bad.
3 to the power of 3 to the power of 2. 9 I can write as 3 to the power of 2. Now and 3 to what can I write this as? So here I had 3 to the power of x cube. How can I write this as 3, 2 and then x outside? What is it equal to?
3x equals 2x.
Yeah, just 2x. Yes, you multiply them. And then what is it equal to?
3x equals 2x.
I mean, it's x to the 3. It's not 3x. It's x to the power of 3
Oh, okay, my bad.
is equal to 2x. You're like, how am I supposed to solve this? Quadratic. This is not quadratic. This is cubic. So what you do is take everything on one side. Subtract 2x both sides. You get x cube minus 2x is equal to 0. Then what you do is you take out x common. When you take out x common, you are left with x square minus 2 is equal to 0. Fifth here. So you got as x square minus 2 as 0. In this case, what you will do is you will put each and everything 0. X is equal to 0 and then x square minus 2 as 0. And then solve this side here. Add 2 both sides. You get x square is equal to 2. Take square root on both sides. Whenever you take a square root, you have to put a plus minus sign. Don't forget that. You get x is equal to plus minus square root of 2. That's your answer. 0 and plus minus square root of 2.
Okay.
So for this, you get 0 and plus minus square root of 2 as your answer. Anyone who did not understand this part and wants me to explain again? I'm giving time for you to practice these. These are important here. You should know how to solve these and find the value of x. And one die.
Hello.
Hello. Let's do the 73rd one. It says a to the power of negative x plus 14 is equal to 16 to the power of x.
So I put 8 in parentheses,
Okay.
negative x plus 14, and it equals, I have to try to find maybe like a common factor between them.
Okay.
So I would do, so I did 2 in parentheses.
Yes.
I did 2 parentheses with 3 or
Okay.
2x. Is it 2x 3 or is it just,
So 8 you wrote in the parentheses, right? 8 becomes 2 to the power of 3 in bracket and negative x plus 14 remains outside the bracket.
okay. Okay. So then it would be negative x plus 14.
What about 16? How can you write 16 as?
Oh, snap. Oh, snap. Okay, hang on. So 2 to the power of 4.
Yes. It will remain inside and this exponent which was already there will go outside the bracket.
Okay. Oh, jeez. My whole life confusing. Okay. And
So-
then,
Mm-hmm.
so that happens. Okay, so then it would be negative x plus 14 would equal x.
No.
Yeah.
My spaces
No.
are still not. You have to open the bracket. I don't want brackets. You have to open the brackets.
Gotta open the brackets.
Which draw you're gonna use?
So you would leave, oh, okay. Oh, I got you. Real quick. So it would be 2
Yeah.
negative 3x.
Yes, perfect.
Oh, the x is on the outside. Sorry.
Plus
And we go to x. It's not
14 times 3. It's a whole bunch of them. 14 times 3. 42.
Is equal to.
And then equals 2 4x.
Perfect.
2 to the power of 4x.
Perfect.
Gotcha.
After this
Then it'd
was
be
the step.
negative 3x plus 42 would equal 4x.
Perfect.
Then you would subtract 4x from both sides.
No, just add 3x.
Yeah, just add 3x.
Okay, yes, slowly but surely I'm getting it. Thank you. So add 3x. Okay,
So you get
add
4
3x. Then it would be 42 equals 12x.
12.
No,
7x.
wait, 7.
7x.
Just kidding. 7x. 7. X equals 42. 6.
6.
X
Perfect.
equals 6.
Perfect.
I can get there eventually.
So in this case, in this problem, you get x is equal to 6.
Jeez. 6.
Perfect. So let's go to 75 here now. So you have
Please.
3 to the power of x square minus 7 is equal to 27 to the power of 2x. So let's see here. Daniel,
I'm here.
okay, let's solve this one together.
Yeah, give me a second. I'm working on that.
Yeah, perfect, yeah. Don't worry, let's work together, Daniel, here.
Okay.
Tell me what's the first step.
So it will be 3 to the power of x squared minus 7
Okay, is equal.
equals 3 to the power of 3.
Yeah, okay. And since you're changing it, so you're gonna put in a bracket, right?
Yeah, a bracket. Then 2x.
Okay.
So it will be. So you multiply the 3 times the 2x. So you got, well, you pass the x squared minus 7 equals to
What is 3
6,
times 2x? Or what is 3 this? What does this become?
6x.
6x. Okay. Now what do I do?
You'll equal to each other.
Yes, perfect. X square minus 7 is equal to 6x. Then how do you solve this?
Minus 6x.
Perfect. Minus 6x.
So you got x squared minus 6x minus 7. And then you use the quadratic formula, am I right?
Yes, perfect, perfect. You got it. When you used, what did you get your answer as?
Give me a sec.
Yeah, do it. It's okay. Take your time. It's okay. Do it. You get your answer as -1.7. Check. Everyone check your answer. You should get your answer as -1.7 for this.
Yeah.
You got those answers, Daniel?
Mm-hmm.
Perfect.
Yeah. Okay, so 64 squared, that's 8.
Okay, let's do the next one. You have 4 to the power of x times 2 to the power of x squared is equal to 16 squared. Okay. Can I have Gerald? Gerald is not there. Erica is not there. Joshua.
Yeah.
Okay, Joshua. Let's do this one here.
Okay.
Okay.
So it's 4x times 2x. So you can get all of them to 2.
Okay.
The vector 2. So it'd be 2 to the power of 2x times 2x squared equals 2 to the power of 4 squared.
Yeah, 4 squared. Okay.
Now that they have all common base, you can just put 2x times x squared equals 8.
2 to the power of 8 here, right? This becomes 2 to the power of 8 because you multiply, right? What about here?
You just get squared, so wouldn't it be 16? Where is the put?
6. Oh, no, I didn't get your question.
Because it's 4 squared, right?
Not 4 square. You just multiply. You don't square it. You just multiply these numbers. You get 8.
Oh, okay.
You don't square them. Yeah.
2x times x squared equal 8.
Yeah. 2x times 2x squared is equal to... No. That's not how you do it. When you have same base multiplication, different exponents, what do you do?
We add.
So what do you get? 2 to the power of?
Oh, so 2x plus x squared?
Yeah, 2x plus x squared is equal to 2 to the power of 8. You should have only one term. One term, different exponents. You cannot have 3 terms here.
Okay.
For equating. So once you got this, what do you get, Joshua? Yeah, 2x is equal to 8. Yes. How do I solve this? Quadratic formula. Subtract 8 both sides. You get x squared plus 2x negative 8 is equal to 0. Use quadratic formula and tell me what answer you are getting for this. If anyone has any questions, please let me know.
Can you do the quadratic formula for
this
the
one?
last one?
This one?
For 75.
75?
Yeah.
Okay, let's see. X is equal to negative of negative b becomes positive 6 plus negative 6 square minus 4ac over 2a. So it becomes square root of 36. 7 4s is 28. Positive 28 over 2. So you get 6 plus minus square root of, you add them. You get 64 over 2. You got it, anyone? See here, till this step.
Yeah, I just forgot to square the -6. That's why I got a whole different answer.
Oh, okay.
Thank you.
Yeah. Joshua, you got the answer for this?
X equals -2, 4. -2 and 4.
-2 and 4? It should be -4 and 2.
Yeah.
-4 and 2 you got, right?
How's it?
You got this?
It's -2.
You got -2? Let's see how you got it. Let's see.
Yeah, no, that's right. It's no.
So let's see. Your A is 1, your B is 2, and your C is -8. Let's use the formula. It becomes x is equal to -2 plus minus square root of 2 square minus 4AC over...
You can just factor it, right?
Yeah, you can factor it also, yes. It's just for people, since factor, not everyone can do it, so we use quadratic formula. So you get -2 plus minus square root of 36 over 2. So you get -2, -6 over 2, and then negative plus 6 over 2. Which is -8 over 2, which is -4. And here you get 4 over 2, which is 2. So you get -4 and 2.
I have to put negative in front of the 2.
Yeah, perfect. Okay, no problem. Any doubts, anyone so far? Okay, let's do 79 here. 79, Shaira?
Yes.
Okay, 79. How do you do it? So you have e to the power of x as e to the power of 3x plus 8.
Okay, so I know how to do it, but explaining might be hard for me. But okay, I'll try. So since they're the same base, I didn't have to do anything to it. So I just set the exponents to each other, equal to each other.
Perfect. Then?
And then that was equal to 3x plus 8 equals x. And then I took away the x from the other side to put into the other side. So that's on one side. Does that make sense?
Yeah,
oh my goodness,
exactly.
I don't know how to explain.
I'm writing here. See? Yeah.
Okay, and then so it's 2x plus 8 equals 0.
Mm-hmm.
And then I divided 2 from both sides and got x equals -4.
So you got 2x is equal to -8, and then you got x as?
-4.
Perfect. Good. So this is the answers you got so far. Here, okay, can I have was? Is was here? Was is not here. Okay, can I have Karen?
Yes.
Okay, Karen. So let's do the next one. So we have 81.
Okay.
So it says e to the power of x square is equal to e to the power of 3x times e to the power of this thing.
Okay. So if e to the bottom square equals e to the bottom 3x, multiply e to the bottom -2.
Perfect. Yes.
So we have a square root, the square equals 3x. 3x.
So you cannot write it like that, Karen, as yet. You need to combine these two. You're just supposed to have one e on one side, not two e's. One e on one side and one e on the other side. You cannot have two e's. And So how do you do it? How do I make it into one e, both of these?
Square equals 3x Multiply -2.
Yeah. See here, same base. What happens, Karen, when you have the same base
Oh,
multiplication?
okay. It's how to say? What is plus -2.
Yes, exactly. Plus negative 2. Now you have one e on one side and one e on the other side, right? Now you can put it equal to. You get x square is equal to 3x negative 2. And how do I solve this, Karen?
Square equals 3x minus 2.
Yeah, so yeah, exactly. Now you x minus square, both sides you get 0 is equal to negative x square plus 3x negative 2.
Okay.
And then what do you do with this? How do you solve it? So either factors or quadratic formula.
Yes.
So when you use that, you are going to get 1 or 2. Solve, you'll get 1 or 2.
Yeah.
Okay. Hawking?
Yes.
So you're going to give me the next one, which is 83rd. It says, if 4 to the power of x is 7, what does 4 to the power of, it is 4 to the power of negative 2x equal?
So would you start by moving the negative exponent to the denominator?
Okay, you're saying this thing here, right?
Yeah, the 4, yeah.
So you're saying what does it become is, you're saying it becomes 1 over 4 to the power of 2x, right?
2x,
Okay.
Okay. So where do we go from here?
Yeah, exactly. That's the thing. How do we go from here? Do you, any other guess?
That's a good
Try to
question.
use this thing and try to make this as this thing.
Oh. Okay, I see.
You have to make this 4 to the
the
power of x as 4 to the power
4
of...
to the negative 2x equal to 4x? Is that what you're saying?
So let's see. So you have this thing 4 to the power of x as 7, right? I need here is 4 to the power of negative 2x. How do I make 4 to the power of x as 4 to the power of negative 2x? Can I write
you multiply by negative...
Can I write it like this? Is it the same thing?
Yes.
Yes. So if I'm here, if I am raising this as negative 2, I have to raise this also as negative 2.
To the negative 2. Oh, 7 to the negative 2. I get it. Okay.
Yeah. So it becomes 4 to the power of negative 2x as equal to what? What is the value of this thing?
2x, negative 2x minus 2. So you'll set it like equal to each other.
No. You cannot put it
Oh,
equal.
no, because the bases are not the same. I got it. So that would be 1 over 7 squared.
Yeah, which is?
1 over 49.
That's it. That's your answer. They want you to find the value of 4 to the power of negative 2x, which is 1 over 49. Anyone who did not understand how to do these problems? So you don't have to go this way. So you had to find 4 to the power of negative 2x. What was given to you as 4 to the power of x? You did not have negative 2x. So what you do is you multiply this whole thing by negative 2. But if you're doing your left hand side with negative 2, you have to raise your right hand side also with negative 2. And when you solve it, you get negative 2x and this becomes 1 over 7 square, which is 1 over 49. You cannot put equal to each other since your bases are not the same. Good help. Any questions?
I thought that we're supposed to convert the yx from the second step into a 7.
Oh, it's 4. It's 4. This is 4. Okay.
4x.
Yeah, 4x. Okay, so it's 4, and then no, you're not supposed to. That's something. So before questions, what they were saying is, no, the question is different now. Before they were saying solve for x, then you were putting equal to each other and trying to find the value of x. In this case, they are saying if this thing is equal to this thing, they want you to find the value of this thing, 4 to the power of negative 2x. They're not saying find the value of x. They want you to find the value of this whole thing. So that's why you are trying to, you have 4 to the power of x. You're making this 4 to the power of x as 4 to the power of negative 2x. By multiplying this 4 to the power of x by negative 2. But if you're multiplying this side with negative 2, you have to multiply the other side also with negative 2. And then you solve. Did you get it? Everyone? Okay. If you want, we can do one more problem on this. If 3 to the power of negative x is equal to 2, what does 3 to the power of 2x equal? Okay. Can I have Eduardo?
Yeah.
Okay, Eduardo, let's see in this one. So you have 3 to the power of negative x is equal to 2, right? Note, I need to find the value of 3 to the power of 2x. So here I need 3 to the power of 2x. I have 3 to the power of negative x. How do I get here 2x?
Can we convert the 3 to the power of 2x into 3 to the power of 2 over 2x?
If I do that becomes, if you're saying like this, right? Right, Daniel? Oh,
No.
Edward.
No, it's supposed to be b to the power of 2 to the power of x.
So you're saying like this. So here, wait, let me explain you another way how to do it is. So you have here 2x, right? You need 3 to the power of 2x. What I have here is negative x. I want to make negative x as 2x. What should I multiply negative x with to get 2x?
Negative 2?
Yeah. Are you getting it, Eduardo?
Yes, sort of.
So I need here 2x. What I have here is negative x. What should I multiply with negative x to get 2x? Negative 2, right?
Yes.
I have to multiply by negative 2 to make it 2x. So if I am multiplying this with negative 2, I have to multiply this side. I have to raise this also with negative 2. So this becomes 3 to the power of 2x, which I needed. And what is the value of this thing, Eduardo? 2 to the power of negative 2.
It's going to be 2 to the power of negative... No, it's going to be negative 4.
No. Negative exponent. How do I make it positive?
It's going to be 1 over 2 to the power of 2.
Which is 1 over 4.
Yeah, 1 over 2 to the power of 2.
Which is 1 over 4. Perfect. Did you get it?
Yeah.
So basically you try to make this thing as this thing and see what should I multiply to make them same. Whatever you have to multiply, you write it outside the bracket. And 87, you guys do it yourself. It's the same problem. Next thing I'm going to move is to logarithmic. Okay. Okay. So I'm going to logarithmic functions. Logarithmic functions. Okay. So it says, so if you have logarithmic as y is equal to log ax, it is actually equal to, you can write it in the exponential form. You can write this logarithmic into exponential form. How you do it is, take this base here, write it here, whatever y you have raised, 2 power y is equal to x. So basically you take this a here. How can you remember is take this a here, make it into exponential is equal to x. So if you're given this, you can write into logarithmic form. If you're given this, you can write into exponential form. These two are exactly the same thing. So if I say you are given as 1.23 to the power of m. I say you have to write it in the form of exponential. Oh, sorry, this is exponential. You have to write it in the form of logarithmic. How do you do it? Compare. Okay, let's see. Carly?
Yes.
Okay, compare this, and I want you to write in the form of logarithmic. What is your y in this case?
M.
Y here. See here, compare. What's your y?
Oh, 3.
So it becomes 3 is equal to, so remember 3 comes down, log, what's your base?
2.
1.2. 1.2.
Oh, 1.2. Okay.
And then, what's your x?
M.
M. Perfect. So Carly, you're going to give me one more thing, one more example. You're given e to the bar of b is equal to 9. Write in the form of logarithmic.
So it'd be b equals
log,
and then e,
and then 9. So how you can remember is get the base down, so it becomes b. Take this e as in base, and this 9 remains there as it is.
Okay.
Yeah. So can I have Jelena, Axel, Alejandro, now Jose?
Yeah.
A to the power of 4 is equal to 24. Write it in the form of logarithmic.
What's above a?
4.
4 equals log base a times 24.
Perfect. Anyone who did not understand how to do this? How to, if you're given exponential, how to write it in the form of logarithmic? Get the base down. So 4 came down. This, whatever is your base, will become the base of logarithmic now. And then 24. Similarly, you can change from logarithmic to exponential. So if you're given something like log a4 is equal to 5. Log a4 is equal to 5. And Wandai?
Yes.
Okay, write this in the form of exponential.
Okay. A.
Mm-hmm.
No.
Yeah, you're
A
correct. Mm-hmm.
equals.
No. So you take this
A log. No, A5.
Yeah, a to the power of 5. You take this base here, this will become your new base. Here it was the base of a, this will become the a base of exponent. So you take this
So A5
is equal to?
equals log.
No. Just 4.
No. Oh.
From here,
A5 equals 4.
Yeah, you compare here, right? And Wanda, do one more question for me. Log EB is equal to -3.
Log EB. Okay. So E equal E -3 equals B.
Perfect. All right. Okay, Daniel.
I'm here.
Yeah. Okay, let's convert this into exponential. What does it become?
Can you put it more up?
Yeah.
I cannot see it. Log 1. Okay. 3. See. So it will be 3 at the power of c equals 5.
Perfect. So this is how you convert from exponential to logarithmic and logarithmic to exponential. Okay. Next thing we're gonna do is it says find the exact value of logarithmic function. They want you to find the exact value of logarithmic function. They want you to find the value of log to 16. They want you to find the value of log 216. How you can do it is, okay, you're like, I don't know how to find it. I put it equal to y. I say the answer of this thing is y. Basically, they're asking you to find the value of y. Okay, I assume it is y. You can assume x, y, whatever you want. Now what I'm gonna do it is I'm gonna write it in the form of exponential because I know how to solve exponentials. I'm gonna write it in the form of exponentials. Gerald is not there, Erica is not there, Joshua.
Yeah.
Can you write it in the form of exponential? What do you get this?
2y equals, does it say pound?
16. 16, right? What was your question?
2y equals 16?
Yeah, is equal to y is equal to 16. Okay. And then when you solve it, how do you solve this, Joshua?
You make it to be, the 16 has the same base, so
Yeah.
2 to the power of 4.
Yeah, 2 to the power of 4. What happens then?
Y would equal to 4. You just get rid of the bases.
Perfect. That's what you needed. You need to find the value of y because I need to basically find log 216, which I assumed as y. So basically I'm finding the value of y and I got my y as 4. Let's do one more problem. So if I say find the value of log 3 over 27. Okay. Christopher?
Yes.
How do you do this one?
Okay, so it would be 3 to the power of x or y, whatever one, is equal to 1 over 27.
Okay, perfect.
Then we're going to change the base of the 27 to 3.
Okay, so what do you get?
So then it would be 3 to the power of 3.
Okay.
But it would 3 to the power, yeah. And then you'd flip the 3 to make it not a fraction.
So what does it become?
And then it would turn negative.
Okay. What do you get?
So
y?
then it would be 3y is equal to 3 to the power of negative 3. Then y is equal to negative 3.
Perfect, perfect. Good. Any questions, anyone? Okay. Let's do more problems. Okay. So you are given log 3 4x minus 7 is equal to 2. You need to solve for x. Hugo?
Yeah.
Okay, let's solve
So
this.
my x is gonna be 3 to the power of 2.
Is equal to?
It's equal to 4x minus 7.
Okay, solve.
Okay, so just a second. I think I'm gonna need some help with this one.
Okay, 3 square is?
3 squared is 9.
9 is equal to 4.
So I'm gonna solve for 9. So it's 4x plus 2. It's gonna be 1/2.
Yeah, 16 is equal to 4x, and then you divide by 4, and x is equal to?
4.
Perfect. Did you get it? How I got it?
Yes, I did.
Perfect, perfect. Let's do one more example. So you have log x 64 is equal to 2. Log x 64 is equal to 2. Miguel is not here. Angel?
Yes.
Help me solve this.
Log x 64 equal to 2 is gonna get
How do you write it as an exponential?
hang on. I'm trying to.
Yeah.
Oh, so it's going to be x to the power of 2
is equal
to 64.
Perfect. So how do you solve this? I just need x.
Pretty much just square root.
Okay, I take a square root on both sides. What do you do when you take a square root?
Plus or minus.
Perfect. You get x is equal to plus minus. Square root of 64 is?
64, 8.
8. Perfect.
Positive negative 8 plus minus 8.
Yes. Good. Okay. The last kind of question we are doing today is if you have e to the power of 2x as 5. You need to find the value of this thing. You're like, oh, I don't know how to solve this. Even if, you don't know what is e. You don't know what is the value of e. You cannot write 5 as e if you don't know what is e. But what you can do is, so remember one more property, note here. So if you want to make a note here. Okay. ln is a special, ln is a special kind of log. ln is a special kind of log with base e. Actually, ln is log with base e. ln is log with base e. In this case, what happens is you need to remember is ln of e. ln of e is actually equal to 1. ln of e is actually equal to 1. You should remember that. So, remember this thing here. ln is basically log e and ln of e is basically 1. What you're going to do is in this case, when you have this thing, whenever you see e in your question, if you can solve. If you cannot, what you're going to do is you're going to take ln on both sides. So it becomes ln e to the power of 2x is equal to ln 5. And this thing is 1, so you're left with just 2x is equal to ln 5. And since I need just x, I'm going to divide it by 2. I get x is equal to ln 5 over 2. This is your answer. You can always see on your calculator also they have separate. See here, log is separate and ln is separate. Log usually in here in this calculator, this log has base as 10 in general. But this ln will always have base as e. So this is a one different kind of problem. So whenever you see e and you cannot make e this side. So what you do is you take ln on both sides. This ln e will get cancelled. Only the exponential part will be left and then solve here. And you can use your calculator to find the value.
So 1 to the power of 2x just becomes 2x.
So the thing is there is properties we are gonna do. What happens is it's not ln e is 1, but it happens. Let me explain. So there is this property which we are gonna do later. So if you have this exponential here, log m to the power of, you can say n. It is actually equal to n. This property we are gonna do it. So in this case, what happens here? You have log e to the power of 2x, right? With ln, I told you ln is log e, right?
Yeah.
So it becomes basically 2x. We will be doing this property tomorrow, actually.
Oh, okay. Yeah, that it's a little bit confusing, but it's just like seeing it in the log form with log base e.
Yes, we haven't done log properties right now. I just explained you how to convert log to exponential and exponential to log and how to solve. We haven't gone to the properties as yet, but this problem itself uses some properties. So you just remember this one and that's how you remember. I'm going to explain you in details tomorrow. We have another chapter, another section on this thing only, logarithmic.
Okay.
Yeah. Any other questions, anyone? Okay, so that's it for today. I'm gonna assign you homework on this, and then tomorrow we'll be doing section 5.5 and 5.6. Okay, thanks guys. Okay, let me just see. People's attendance who I don't have is was Miguel, Erica, Gerald, Jesse, Alejandro, Axel, Jelena. That's it.
Wait, just people who aren't here?
Who aren't here. And if they're here, they can. Yeah, everyone else. Thanks, guys. Have a nice day. See you tomorrow.
Wait, I was here though.
Thanks.
Oh, Axel was here. Axel, you stay
Yeah.
back. I called your name twice. You did not answer.
I only heard it once, and you was when you were speaking through names.
Oh no. I was calling before also.
What? I asked maybe if it was at the beginning, it was because I was looking for the code to go into the class.
Okay. No problem. Okay. Thanks, guys. I marked you. It's okay.
All right, sorry.
And
Thank you. Have a nice day.
You too. Have a nice day. Where were you was the whole lecture? I cannot hear you. You're mute.
Can I review the first part? Sorry.
Which one?
The first part of the lesson?
So what I'm gonna do is I'm gonna upload this video right now. I've recorded it. I'm gonna upload on
Okay.
Canvas. Okay, along with the notes. Try to understand. If you don't get it, I'm gonna explain. Come early tomorrow a little bit or stay after the class and I'm gonna help you, okay?
Okay.
Okay, perfect was. I'll see you
Okay.
tomorrow. Perfect.